Hello, I'm Robert Randall, often called Sandy, and with me here is my wife Carol, who encouraged and helped me at every step of the way. We built our zero-energy home to be our retirement home. My saga started during the fuel crisis of 1973, when I began to think about how to reduce my dependency on heating oil and make a super-efficient house. It was frustrating how hard it was to find good technical information on solar energy. I struggled through several design concepts, and it was not until 1999 that I was able to glean enough facts to feel confident about setting out to build a zero-energy home. The original sketch design was pretty much the same as what I ended up building in 2006. I had to take a course in AutoCAD computer drafting to be able to turn those sketches into detailed construction drawings. The challenge is actually pretty simple. Provide enough sustainable energy to offset total energy demand of the house. I dismissed wind energy because our location has insufficient wind resources to be a practical part of the solution, so I chose to go with solar power. In 2006, solar power was far more expensive than today, so it made sense to try to make the energy demand as small as possible. It still does. Energy conservation is cheaper than energy production, and the design features aimed at reducing energy demand, that is, heating and cooling loads, have the secondary but very important benefit of making a house more comfortable year-round with desired temperatures distributed uniformly through the house. The construction incorporates SIPs, structural insulated panels with a thick core of foam insulation. I chose 8-inch panels in the walls and 10-inch panels in the roof. The thick panels led to wide windowsills, which Carol loves for accommodating her indoor plants. The windows were chosen with care. Expensive triple glazed windows reduce the winter heat loss and summer heat gain to a small fraction of the heat loss or gain of traditional glazing. Awning-style windows provide maximum unobstructed view and minimum air infiltration, otherwise known as drafts. 2/3 of the windows face south for maximum passive solar heating in the winter. But the liability of summer solar heat is real, so the windows are sized and situated so that in summer they are shaded by architectural projections above. On the main floor, the shading is provided by carefully designed roof overhangs, and on the lower floor by a projection of the floor above. In the summer, no direct sunlight falls on these windows. This is very important in keeping cooling loads to a minimum. Likewise, the 10-inch SIPs on the roof keep the heat build-up to a minimum. With all these energy conservation features, the heat loss in the coldest winter weather is about 10,000 BTU per hour, about 1/10 of the heat loss of a conventionally built house of the same size. The energy demand of appliances is of course part of the picture, and an electric stove, electric clothes dryer, and electric water heater all contribute to the total energy demand. The house is heated and cooled by a geothermal heating and cooling system, more correctly described as a ground source heat pump system. My calculations suggested a heating and cooling load of 1 ton, or 12,000 BTU per hour. The availability of suitable high-efficiency equipment led to the installation of a 3-ton water furnace geothermal heat pump, water to water, with 3 200-foot wells in the ground loop. It runs about 1/3 of the time in coldest weather. Heat is distributed by radiant floor heating, incorporating PEX tubes embedded in a 2-inch topping slab over the 8-inch hollow core precast concrete plank deck, which supports the main floor. This construction provides a very large thermal mass to absorb the incoming passive solar energy on sunny winter days and release it slowly during the night. With the radiant floor heat, you can walk around barefoot all winter long in complete comfort. We installed a small high-efficiency wood stove as a backup heater and also for the nostalgic pleasure of having a small fire on a cold winter night. When using the wood stove, the geothermal heat has to be set down to avoid overheating the house. Interestingly, the radiant heat of the main floor also radiates upward and downward to heat the downstairs and the upstairs. We call them by those names because the downstairs, while actually being the foundation level, is by design comfortable living space with half of the south-facing windows, making it bright and cheerful living space. As we set it up, the downstairs houses the library with big screen TV as well as the guest suite. 2-ton chilled water air handler, also by water furnace, hidden in a closet upstairs, provides the air conditioning for the whole house. Calculations suggested a 1-ton unit, but equipment availability led to the installation of a 2-ton unit, which predictably runs only about half of the time. The geothermal system has 2 features which I consider to be pure serendipity. The first is the de-superheater, which delivers a stream of waste heat via hot water to a preheat tank in a domestic hot water supply, providing hot water feed to the electric water heater, thereby reducing the amount of electricity used. The second bit of serendipity relates to the seasonal thermal cycles of the ground loop with its 3 200-foot wells. During the winter, in heating mode, the wells draw heat from the surrounding earth, chilling it by several degrees as the winter goes on, creating deep cylinders of cold earth. When cooling season arrives, the process is reversed and the heat pump dumps heat into the same earth to cool the house. As the cooling season progresses, the earth becomes a heat sink and warms substantially, thus providing significant added efficiency to the following heating season operation. Over the first year of operation, the net increase in electrical consumption turned out to be the equivalent of a $400 annual cost for heating and cooling the entire house. That surprising result was probably due in part to the reduction in the electrical use for domestic hot water. The heat pump heats or cools, depending on the season, water in the geothermal buffer tank. In cooling season, as right now, chilled water runs through those tubes up to the air handler to provide air conditioning for the house. In heating season, hot water from the buffer tank runs through these pipes over here to the radiant floor heating system. There's the circulating pump and the controller. And over here is the radiant heat manifold with 5 zones, one for the master suite, one for the living room area, one for the kitchen and dining room, one for the greenhouse, and one for the screen porch, which we've never activated. The original photovoltaic system is a 4.1 kilowatt grid-connected system incorporating 16 RWE shot roof-mounted panels of average 256 watt production, served by 2 Selectria 2500 watt inverters. It has been functioning flawlessly since August 18, 2008. The panels are mounted on a 12-12 pitch roof facing due south using custom fabricated aluminum standoffs, providing 6 inches of ventilation below. The installation was done by me with help from a few friends and a licensed electrician, Jonathan Bosworth of Bridgetown Electric, who also wired the entire house. Jonathan's enthusiasm and knowledge were immensely helpful. The newer PV system of 3.2 kilowatt nominal capacity incorporates 11 REC 290 poly panels and a SolarEdge StoreEdge 7600 inverter with 11 P320 optimizers. Also installed is a 10 kilowatt hour LG Chem storage battery unit. The panels are mounted on factory-made mounting tracks on a 12-12 pitch south-facing roof of the garage, which we call the barn. This system was designed by John A. Mara, Jr., then Solar Energy Systems Incorporated of Millersville, Maryland. It was challenging for multiple reasons, including the very untraditional construction details of the house and the presence of the pre-existing 4.1 kilowatt system. John was extremely knowledgeable and unendingly helpful. We have become good friends. The battery backup system was designed to provide for 2 days of backup operation of the critical loads panel, powering 2 freezers, the refrigerator, the well pump, septic effluent pump, and general lighting. It does not power the electric stove, the clothes dryer, or the geothermal heat pump. During an actual test, it served for 4 days. The design, however, provides for PV panels to recharge the battery during any periods of sunshine, making the outage survival much longer. The switchover during an outage following Hurricane Isaias was so seamless that we only knew the power was out by looking at the lights on the electric stove, which were, of course, dark. The battery gives us electrical backup without the necessity for any kind of fossil fuel on the premises. A key objective of the project was to make a house which was truly a zero net energy home, but which did not present as an industrial or freaky geeky house. The interior layout was based on our experience living for many years in our previous home in suburban New York, where we had raised our 2 daughters. We wanted to build a retirement house where they would feel at home. We also tried to anticipate our needs as we aged, so the master suite is on the main floor, which has an entry at grade. We incorporated 3-foot doors and a roll-in shower with ADA grab bars and a folding seat. Carol and I spent a lot of time reviewing the design in great detail, down to furniture placement in the kitchen and dining area, and assuring that the kitchen layout would accommodate her standing mixer. Careful consideration of design details was important as we were trying to follow the advice of Stephen Strong, founder of Solar Design Associates, who advises that rule number 1 for solar home design is to make it as small as you possibly can. The success of the effort has been undeniable. Between the 2 upstairs bedrooms, the guest suite, and fold-out sofas in the library, we have been able to sleep 11 guests in comfort. The ultimate confirmation came from our 8-year-old granddaughter, who told us during a recent visit that when she comes here, she always feels like she's at home. And with the revenue from sale of SRECs, our annual utility bill is less than 0. In the preceding description, I have glossed over a lot of technical details to keep the story simple and readable. I'm considering writing a book on the subject and addressing all these technical issues in full detail. It is only fair to mention that in my working career, I was self-employed as an architectural engineering consultant, occasionally providing engineering services on renewable energy projects, including wind turbines and commercial photovoltaic systems. I have also designed many homes, even more building additions, and authored numerous magazine articles on construction details and issues. I must point out that to successfully plan, design, and build a zero-energy home, considerable expertise is required. There are a lot of ways to go wrong, and it is a very serious undertaking. The areas in which I have most commonly seen shortcomings are failure to do the math. Energy demand and supply is readily subject to explicit calculations by those with proper knowledge. False economy on insulation and windows. These areas are incredibly important to successful outcomes, which mean comfortable homes. Buy the best you can. Selecting mechanical equipment based on price rather than performance. Efficiency is very important, as is quality. These attributes are rarely found in the cheapest equipment. Don't be taken in by the notion that bigger is better. This applies to houses in general and especially to heating and cooling equipment. HVAC contractors typically oversize their equipment by a factor of 3 or more. Ideally, a factor of 1.0 on maximum required capacity is appropriate. The frequently seen term safety factor is often used to conceal ignorance and the inability to actually calculate the required capacity. I heartily advise anyone considering building their own home to read The Healing House by Barbara Harwood. No longer in print, it can be found used on Amazon for about $6. You really should read it. I won't try to describe the important lessons she so well describes. Thanks for listening. Acknowledgements. I had a lot of help from friends and family in building this house. Old friends Steve Lazarchak, Tom Lewis, Bob McDonald, Avery Rosen, Bill Correo, and Dominic Giusti were very generous with their time and effort. Most significantly, my son Chris Randall was immeasurably helpful both in assisting me with AutoCAD and also with huge amounts of hands-on help during construction. He continues to be an inspirational well of knowledge. Somewhat off topic, the house is built around a traditional timber frame expertly made in Vermont by Northwoods Joinery. Pete Kachalka and Larry Cruz were the principals, and this was just one of many timber frame projects on which we collaborated. Regretfully, Larry has since passed away, and there is never a week when I don't find myself thinking of his kindness and wisdom.